Hello, wonderful students. I wanted to go over the Chapter 5 tests, 5A, 5B, 5C. We're going to start with 5C, sequences. So number 1 says, for the following, identify if the sequence is arithmetic, geometric, or neither. So for the first one, we're going to recognize that this thing is going from positive to negative to positive to negative, meaning there's no way we can add a number and get the next term consistently. So this one is going to be geometric with actual multiplier of -3. Remember, there's actually a trick where you can use the first two numbers to decide what the multiplier is, right? What do we do? We take -6, the second number, and divide it by the first number. Yes, so -6 divided by 2 is -3. And we can go ahead and check if this truly is a geometric sequence. 2 times -3, -6. That times -3, 18, -54, positive, negative, positive, negative, positive, negative. Notice how the numbers are changing because it's being multiplied by a negative number. Next one is going to be arithmetic. This one is adding a number consistently each time. What is it adding? We can actually figure it out by doing -1 minus the previous number. -1 minus -5. -1 minus -5 is going to be +4. This means these numbers are going up by 4. It's a little easier to tell here that the numbers are going up by 4, and this is going to be arithmetic. Okay, number 3, or letter C, sorry. That one's going to be neither. There's no arithmetic or geometric pattern that's going to match this. So it's not adding the same number each time, it's not multiplying by any number each time as well. So that one's neither. Okay, letter D. That one is going to be 27931. That's going to be geometric. This one is being multiplied by 1/3 each time. How do we figure that out? Again, let's try the trick. 9 divided by 27. That's going to be 0.33333, which simplifies to 1/3. That's going to be consistently 1/3 of the previous number. Geometric is the correct answer. All right, last one here, 82021818. This is a list of numbers that doesn't have a reasonable pattern that could be either adding or subtracting or multiplying or dividing by any numbers. This one is also going to be neither. All right, let's move on to number 2. Given the equation, identify the zeroth term and common ratio or difference. So this first one, letter A, this is going to be a geometric sequence in the form T of n equals A times B to the n, where A is the starting value and B is the multiplier, also known as the common ratio, or R. So for this first one, 3 is going to be our starting value. That's going to be our term 0, our starting value. And our ratio is going to be the number in parentheses, the 4. There is no common difference. It's a common ratio. Okay, the next one, we're going to go ahead and identify this one as an arithmetic sequence. Which is typically in the form mn plus b. M is the slope or common ratio Oh, sorry, common difference. Difference, letter D. And B is the starting value. Well, we know that this form can be rewritten. The number in front of n is your slope. So we know that 3 is our common difference. 3n minus 7. Now, the floating number, -7, is going to be our starting value. So our t0, our starting value, term 0, is -7. And there is no common ratio since it's arithmetic. All right, number 3. Number 3, we're given an equation and we're determining if it's possible to have a value of 200. If so, which term number is it? So this equation that's given to us is going to be geometric. The starting value is equal to 5, and the multiplier, or the common ratio, is equal to 2. So what I'm going to do is I'm going to create a list of numbers that starts with the number 5 as term 0, and I'm going to keep on multiplying by 2 to get the next number. And let's see if we ever can get to the number 200. Let's try. 5 times 2, 10. That times 2, 20. That times 2, 40. Do you think we'll ever get to the number 200? Let's keep on going. 80. 160. And let's multiply that by 2. 320. You see, we can definitely say that the answer is no. Justify why not. 200 is not a term in our sequence. As shown above, it would be between those two numbers. Okay, let's move on to number 4. Find the next 3 terms in this sequence right here. This one is going to be a neither sequence. It's not adding the same number, it's not subtracting, it's not multiplying, it's not dividing. This one has a different type of sequence. Well, we can still recognize patterns that might happen here. The first pattern I can recognize is, what are we adding each time? This one seems to be adding 3. Then it seems to be adding 5. Then it seems to be adding 7. So what do you think we would add to get to the next number? Right? We can see that these are all the odd numbers that we're going to continuously add the next number. So if we do 16 plus 9, we're going to get 25. And if we add the next odd number, if we add 11, we'll get 36. And if we add, what's the next odd number? 13. We'll get the number 49. So that's one way to recognize the pattern that's going on here. The second way to recognize a pattern here is this pattern is actually the number 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, ... The pattern here is actually just all square numbers, right? So what's 1 squared? 1. 2 squared, 4. 3 squared, 9. 4 times 4, 5 times 5, 6 times 6, and 7 times 7. This is going to be the next 3 terms there. All right, now number 4b, given term number 1 equals 3, and this is going to be a recursive situation, we want to go ahead and find the next 2 terms. So this recursive situation says to find the next term, we must square our previous term and add 2. So what we have to do for the first value we need to find is we need to take the number 3, the first number in the sequence, and we have to do this pattern. We got to take 3 squared, and we have to add 2 to get to the next number. So what's 3 squared plus 2? All right, 3 squared is 9. 9 plus 2 equals 11. So that gives us the next term. Term number 2 is 11. So term number 1 was 3, term number 2 was 11. Now let's apply the same pattern to get the next number. Square, and then add 2. Well, what's 11 squared?
The answer is 121.
121. Then we have to add 2. What's 121 plus 2? 123. So term number 3 is 123. All right, let's keep going. We gotta get to the next standard, which is standard 5A. Okay, so standard 5A, we have to recognize that this is going to be an arithmetic sequence. It's all arithmetic sequences, 5A. So we're going to go ahead and recognize the pattern as quickly as we can to identify the pattern that's happening in the table. So the pattern that's happening is going to be the numbers are adding by 4 each time. So if I work backwards and subtract 4, I will get the number -9. And if I want to get to the 10th term, I got to do the ... to get all the way to the 10th term. So let's see. Term number 4 is 3. Term number 5 is 13. If we keep adding 4, we'll get to term number 6, term number 7, 8, 9, and 10. I think I made a mistake. Let's try again. So term number 4 was 3. Okay, term number 4 was 3. So if we keep adding 4, we're going to get 7 for the 5th term, 11 for the 6th, 15 for the 7th, 19 for the 8th, 23 for the 9th, and 27 for the 10th term number, because the difference is going to be 4. All right, this one we have to write the explicit equation for the situation. So we need to write it in the form mn plus b. What's the common difference? The common difference is going to be adding 8 each time. So 8n. What's the starting value? Let's go ahead and subtract 8 and get -14. What's the 12th term? Let's go ahead and plug the number 12 into our equation. 8 times 12 minus 14. 8 times 12 minus 14 gives us an answer of 82. Is the number 122 in the sequence? Let's check. A great way to check is to plug the number 122 in for the term value output and solve. So 122 is the output, literally the output 122. And we can go ahead and solve for n, which is the term number. Step 1, add 18. We will get 122 plus 18. Let's see. 140. 140 equals 8n. So let's divide by 8. And we get that the answer would be 17.5. I must have made a mistake somewhere. Let's see. 122 plus 18. I wrote the equation wrong. My apologies. So it's 8n minus 14. So if we add 14 to both sides, we'll get the correct answer. 122 plus 14. Let's correct that. 122 plus 14. 136. Divide by 8 and get our answer. 136 divided by 8 is 17. The answer is that it is a term. It's term number 17. Is number 86 a term number in our sequence? Let's check. So we're going to go ahead and add 14. That will give us 100 equals 8n. Divide by 8. And we know that the answer is 8 does not go into 100. This would be 12.5. 12.5 is not a term number, so we can go ahead and say no. Number 2. Use the sequence to answer the following. What are the next 3 terms? So let's go ahead and figure that out. The pattern here is going to be subtracting 7 each time. So if we apply the same pattern, we're going to get our next terms. -9. Let's subtract 7 again. -16. Subtract 7 again, and we'll get -23. What's the 0th term? The number in front of it. So if we work backwards, we'll get the number 19. What's the explicit equation? Common difference. Starting value. Done. All right, number 4. Wreck-It Ralph unleashed a Cybug virus in the game Hero's Duty. 3 minutes after the virus began, there were 19 total Cybugs. And 7 minutes, there were 43. Let's do some calculations. So 3 minutes, there was 19, and 7 minutes, there was 43. So if we create a table, we can go ahead and figure out what the common difference would be. What actually worked out was a common difference of 6. So the common difference was actually 6, and if we work backwards, we got a starting value of 1. So that's our equation, and it asks us to predict how much would there be after 30 minutes. So term number 30 would be 6 times 30 plus 1. That would be 181 bugs. And here are the answers for 5B, geometric sequences. The most common mistake one was this one, where the numbers are negative, then positive, then negative. But remember to apply the trick to figure out your multiplier. If we do 72 divided by -144, we'll get an answer of -0.5. So the multiplier is cutting these numbers in half, but also switching them from positive to negative. Keep that in mind. Check your answers and let me know if you have any questions.